linear recurrence equation, we have 9a sub n plus 2 minus 6a sub n plus 1 plus a sub n equals 1/3 raised to the nth power, where n is greater than or equal to -1, and initial condition a0 is 0 and a-1 is 0. So the first thing we're going to do is solve for the characteristic equation. Basically, we'll look at the homogeneous case. In other words, when this is equal to 0. So we'll write it as 9n squared minus 6n plus 1 equals 0. I can factor this out into 3n minus 1 quantity squared and get that n is equal to 1/3. There's going to be two roots, but they're both the same. They're both 1/3. So then the solution will be C1 and then 1/3 raised to the nth power plus C2 times n multiplied by 1/3 raised to the nth power. So this is the homogeneous case. And now we just need to solve for the particular solution, which, because 1/3 is the root twice, the particular will be of the form C3 n squared times 1/3 to the nth power. Okay, so the square here means it's twice. Okay, so then we have to plug it in back to the original. So rewriting the original, we have 9a sub n plus 2 minus 6a sub n plus 1 plus a sub n is equal to 1/3 to the nth power. So now you can think of this as the particular solution. So if you want, you could just think of this as p sub n plus 2, p sub n plus 1, p sub n. So then we're looking for p sub n plus 2. That means we'll substitute n plus 2 in for n. And then we have C3 n plus 2 squared, 1/3 raised to the n plus 2, minus 6 times, and then C3 n plus 1 squared, 1/3 to the n plus 1, plus, and then just the original. Actually, so the original was C3 n squared 1/3 to the nth, and that's going to all equal 1/3 to the nth power. Okay, so now we need to be careful how we do this. So if we look at all of these, okay, what do we have in common? Well, we have a C3 in common, and then we have a 1/3 to the nth power in common. So let's factor that out. So we have 9, oh no, actually, before we do that, we have a C3 1/3 to the nth power. Okay, then we start 9 n plus 2 squared times 1/3 squared minus 6. So this is one of them. And I'll just put parentheses 6, and then we have n plus 1 squared times 1/3 to the first power plus 1, or plus n squared rather. And that's going to equal 1/3 to the nth power. Now notice we have a 1/3 to the nth power on both sides, so that's going to go away. Then we have 1/3 squared times 9. 1/3 squared is 1/9. That's going to cancel out with a 9. We have 6 times 1/3. That's going to give us 2. So let's simplify this further. We have C3, and then we have n plus 2 squared is n squared plus 4n plus 4. Okay, that's 1 minus, and then we have 2 times n plus 1 squared. So that's 2n squared plus 4n plus 2 plus n squared equals 1. Because the 1/3 to the nth power, when we canceled it out, it became 1. Okay, so then we just keep going. C3, and then in parentheses we have n squared minus 2n squared plus n squared. That's going to be, those are going to cancel actually. We have 4n minus 4n. Those also cancel. 4 minus 2, that's just going to be 2. So a lot of things cancel, so we have 2 in here equals 1, so that means C3 is a half. So the particular solution, so if we go up here, that was our P sub n, was C3 n squared 1/3 to the nth power. But remember, C3 is a half, so that's 1/2 n squared, and then 1/3 to the nth power. So this is the particular solution. So to get to the whole solution, we need to combine the particular with the homogeneous solution. So that was C1 and then 1/3 to the nth power plus C2n 1/3 to the nth power plus 1/2 n squared 1/3 to the nth power. But the problem here is we don't know what C1 and C2 are. Okay, so we need to use the initial conditions to solve for them. So recall, we had a sub 0 and a sub negative 1 were both 0. So if I plug in n equals 0, I better get 0. So let's see. So we have C1, 1/3 to the 0 is 1, plus, if I do C2 times 0, that's 0, so I don't need to multiply that. And then 1/2 times 0 squared, okay, that's also 0. So we have C1 is equal to 0. And I'm just going to put a sub n here. And then if I plug in n equals negative 1, I better end up with 0. So if I plug in negative 1, I have C1 times 1/3 to the negative 1 is 3C1. And then if I plug in negative 1, I have 1/3 to the negative 1 is 3 times negative 1 is negative 3. And then we have 1/3 to the negative 1 is 3. Negative 1 squared is 1 times a half, so it's going to give us 3/2. That equals 0. But then we said C1 is 0, so ignore that. Add 3C2 to both sides, and then divide by 3 to get 1/2 is equal to C2. So then we just go back to the solution. We say, well, C1 was 0, get rid of that. C2 is a half, and then combine that with the particular. So the particular solution was 1/2 n squared times 1/3 raised to the nth. And so this is the final answer.